Hello everyone and welcome to Maths with Mix Longridge. I'm your host Mix Longridge and today we're going to be delving into one part of maths which does confuse a lot of people. However, when you get the hang of it, you're flying. It's algebra. It's that part of maths where we don't just deal with numbers, we're also dealing with letters as well. Now, it may seem very confusing at first. However, it's an excellent topic to know and it's something which you'll be seeing in all the way through going to school, and even if you go into gymnasium, you will be seeing this. So you can't get away from it, unfortunately. Their rules, not mine. So we're going to be looking at algebra today. We're going to be going through all the different keywords which you'll see while we're going through this topic as a bit of a refresher, as well as a few little problem-solving questions right at the end, so you can have a good idea about what to kind of expect and how we can apply our rules of algebra into deeper examples as well. We see algebra a lot. If we deal in, say, science, in physics, there are loads and loads and loads of bits of algebra which we use. And it gives us calculations, but if we don't know a certain value of our calculation, we can put it in there. And that's very helpful. If you're building a house, you probably want to know how many bricks you need to buy, because buying too many, you're wasting money. Buying too few, and well, you're going to have to buy more bricks. Disaster. So, let's get started. First things first, what we're going to do is looking for key terms and the rules which you need to know about algebra. Okay, so let's go through some of the key words here. There's some English and Swedish translations just to the left right there. They are some of the key words which you'll need to know to get that reasoning sky high. So let's go through these, and I've got an example on the board here of what we call an algebraic expression. Now, why is it algebraic? Because we've got an unknown there. We don't know this x. It's a letter and there's a bunch of numbers. Ew. So we're going to deal with that. Now, the difference between a numeric and an algebraic one is basically, can you put in a calculator and get an answer out of it? In other words, numeric expression, you just have literally numbers and operations. So for example, 7 plus 3. 7 plus 3, that's 10. We can put that in a calculator and we will get an answer. Hurrah! However, it's not quite the same, because not only does an algebraic expression have numbers, it also has operations, but it also has variables. So that comes to our first keyword which we need to know, and that is variable. Now, what we mean by a variable, to simplify, in this case it would be x, is basically an unknown value or a mystery number, basically a mystery number. In this case, it's x, and we usually like to see this in the form of a letter. You'll see x an awful lot, but you sometimes see n, a, b, and so on and so forth. You might see more than one in an expression. You might see x and y. Hey, we might even throw z in there, just to spice it up a little bit more. However, it just obviously depends on the question, but if you see a letter there, it's a mystery value. We don't know it, unless if we get given the information about that, or if we have an equation, which we'll get to later. So, for this one here, variable in this case is x. Now, moving on to our next part here, we have a term. Now, terms are basically, they are separated by operations. They're kind of separated by operations. They are basically what makes up our expression or equation. So, in this case, we have, for our example here, 9x plus 5, we actually have two different terms here. Our first term is 9x. 9x is our first term. And then our second term is that pesky 5 right there. Now, what I would say is, keep a plus in there. It'll help us when we simplify later, because symbols, they can get a bit dangerous when we start doing simplifying. Throw a negative in there. Ooh, nasty. So, for this one here, we have two terms. I might even add on there a plus 4y. Therefore, that 4y would be our third term. Then I could add a minus 2z. That would be our fourth term, so on and so forth. So it's very important to understand what a term is, especially when we get on to simplifying later in this video. However, for now, just be aware of what a term is. Now, the next thing is coefficient. Coefficient, nasty word, you only really see it in maths, no other subjects sadly. However, in this case, we have one coefficient. The x coefficient here is 9. It's basically what do we multiply our variable by? Because what actually is going on here between that 9 and that x is the glue that's keeping them together is actually multiplication. We don't like to put multiplication symbols in algebra. We tend to get rid of them, mainly because we use x a lot, and having like a crossy x and a curly x, it confuses things. So we just get rid of them. And part of algebra, part of the goal of algebra is to write things as short and sweet as possible. In this case, 9 is our coefficient because we're multiplying it by our variable, which is x. So 9 times x. If we have, for example, 13y, y would be our variable. This is a single, and this whole thing's one term, but 13 would be our coefficient. So that's what a coefficient is. In this case, we've got 9x. If I had like a minus 7y at the end there, it would be negative 7. So just keep an eye out for that. It will help later on, especially, once again, when we're simplifying and even solving as well. So there's that. Next one we have is a constant. Now, this is basically, no matter whatever number I have as x, that x could be 20, it could be 19, it could be 84, it could be 7.4444441, for all I know. I've not got enough information there to let me know what it is. However, a constant is, no matter what x is, we're going to add 5. We're going to add 5. Like, doesn't matter whatever this value is here. We're going to be adding 5. So this is basically what happens, like what always happens. If there was like a negative 2 there, that would be a constant because no matter what happens here, we would always be subtracting 2. Or if we had plus 45 here, we'd be adding 45 no matter what happens with x, no matter what the value is for x. So that is a constant. There's our constant here. There it is. There's our constant. Hello, little constant. So that is what we have here. Now, our next one after this is an expression. This whole thing is an expression or uttryck. So it's basically a bunch of numbers, letters, like numbers, operations, and variables or letters. So we've got here numbers, letters, operations. However, the big difference is here that we do not have an equal sign. If we have an equal sign, we're getting something completely different. We're getting an equation at that point. But at this point, we've only got an expression. How I can turn this into an equation is just by putting equals and putting something that side. We will be moving on to equations later on in this video. However, for now, just understand the difference of what is between an expression and an equation. We'll be getting onto that. Coming up next, we will be writing expressions. In other words, I'll provide you with a sentence, and then we need to understand what they, how we can write them in algebra. Okay, we're now at the stage where we can start looking at sentences and then writing them into expressions. So what we're going to do here is we're going to do a couple examples here, 1 through to 4. Now before we get started, let's just go through a little recap of the rules we have when writing algebra. Now the first one to know is that if you have x plus x plus x, or whatever letter, if it repeats itself, we can simplify that just to write 3x. So in this case, it's basically like I've got an orange, I've got another orange, and I've got another orange. How many oranges have I got? 3 oranges. And then just replace the word oranges with the letter x. So you've got 3x here. If we had a plus a plus a plus a, we would have 4a. Now, just be very careful about the symbols. We'll get onto that when we're doing simplifying expressions, which will be coming up just in a bit. But first, just be aware of that. Also, another rule here, if we are multiplying a number and an unknown, otherwise known as a variable, we can just get rid of the multiplication symbol between the two. So in this example here, 9 multiplied by x, we can just write that as 9x. If we have y multiplied by 12, we can write 12y. One thing which is very, very important here is that we write the number first, in other words, the coefficient, followed by the letter or the variable. What I like to think of is number first, letter last. So that's just something to be very careful of. Now, why do we write number first, letter last? It's because in case we get something like this. Now, this probably won't appear. It's something which is quite spicy. However, it's because that is called an index or an exponent. We might have covered that when we did BIDMAS. This here is x multiplied by x multiplied by x. That is also known as x to the power 3, or in the world of maths, we like to just say x cubed. So that's just because that's the reason why we do number first, letter last, if it's just a case of sticking two numbers together. Remember, if we see a number immediately followed by a variable, but the glue which is sticking them together is just a multiplication, just kind of like John Cena, you can't see it. So that is that right there. So let's go on to some questions. The first one we have here is the sum of a number and 12. Now, first things first, there's going to be an operation here. We're writing an algebraic expression. There's going to be an operation. Addition, subtraction, multiplication, division, maybe a square, probably not, but usually one of the first 4 basic operations we have. So in this case, what we need to do is we need to think about our maths vocabulary. In this case, the word sum. The word sum is dead important here. Sum is just another fancy glorified word for addition. So we know there's going to be some addition going on here. Be aware of other words which may pop up. Total is another one. More than is another one. Adding. As simple as that. There's lots of different words there. Be aware of all of them. Be aware of all the different words that we have for addition. There's quite a good number of them, and it's just good to be aware of them because then you can immediately go word to symbol or word to operation, and that makes your life a lot easier. Now, we've got an addition. We need stuff to go with that. We need variables and we need values to go with it because an add symbol, that's not enough. Now, what we get given is the sum of a number. Now, a number. We're not told what this number is, and that could be anything. Could be 702, could be 31, could be 3, could be 7.141, for all we know. It's a mystery. And how do we write mystery number? We can write it just as a variable, so usually a letter x. So we'll stick an x there, and then we are given something else as well. We're told a number and 12. So we're going to get that 12 and we'll stick it on the end there. We've now dealt with all the information here, so that is job done with this question. Let's move on to the second one. The product of a number and 57. Now, once again, let's think about what operations going on here first before we delve in with the number and letter crunching. So we've got the word product. Now, if you look in your maths vocabulary, you'll find that a product is a really fancy word just for multiplication. So we are multiplying stuff here together. Now, we need to be careful with the symbols. We don't really like to write down multiplication symbols. Gets us confused with x, and, well, it makes us write more stuff that we actually need. So we're going to have some multiplication going on here. I'll write it down for now, but we can always get rid of it later. I'm just going to show it using a dot. So we are multiplying a number together and 57. Now, so we're going to have a number, x, and we've also got 57. We're multiplying these together. This is where one of our good to know rules comes in. Number first, letter last. So let's start with the actual number we are given. That's 57. And then we're going to finish with our letter, otherwise known as our variable. So that's going to be x. Now 57 multiplied by x, if we have a coefficient followed immediately by a variable, number followed by a letter, we could just stick together with invisible glue. That will do the job of our multiplication symbol. So that is it, 57x. Number first, letter last. Next one after that is 14 less than a number. So this time, less than. is what we've got. Now, less than. Less than is a bit of a weird one. You've got to be very careful about the order here because 2 minus 1 is not the same as 1 minus 2. One will give you a positive result, one will give you a negative result. That's very careful. It's like between going on holiday to either Thailand, in Thailand, or Tromsø, in Norway. There's a big difference between 20 degrees and minus 20 degrees. Probably not a good idea to take a Canada Goose coat if you're going to Thailand. So, with this one here, less than. Less than, it means we're going to be having some subtraction going down here. So, we're going to have some subtraction, Bob. And now, we're saying 14 less than a number. Just think of it this way about the order. Let's just imagine that our number is 20. 14 less than 20 is 6. So think about what you're doing with 14 and 20 to get 6. You are doing 20 minus 14. So what we're going to do is we're going to have 14 less than a number, and how we're going to express that is x minus 14. We are getting 14 less than a number. Be very careful with the order with these. Other words you might see for subtraction. Common one is difference. You might say obviously less than. We also have subtract as well. Minus, take away as well. Take away, not like a takeaway where you're going to get a banana pizza or kebab pizza, my favourite. So that is that one there. What we have next is the quotient of 18 and a number. Now, quotient. Ew. Quotient's one of those words where you think, oh, gross. All you need to know is just it represents division. That's all we need to know. So division, that is what we mean by quotient. You might see per, you may see divide by, you may see shared by. Just be very careful about these things. So with this one here, quotient of 18 and a number. Well, 18 will go on the top and a number. We don't know that number, so we're just going to replace it with a variable. That value can vary. X. There we go. So we usually like to write it like that rather than 18 with the other symbol, which you may have seen like this one on the front of an Ed Sheeran album called Divide, funnily enough. And this one here. Fun fact, the 2 dots just represent numbers. Mind blown. Found out that when I was like 13, I was like, whoa, that's what the symbol means. But all you need to know is just quotient is division, and then take it from there. Next up, we will have some simplifying of expressions. So careful with the symbols this time. Remember, number first, letter last here. That's one big thing to take away from here. Pardon the pun. This next part, very careful with the symbols. Simplifying expressions. Let's go. Right. What we need to know first of all here is this is also known as collecting like terms. So if you want to do a little bit more research on this, just type in collecting like terms. Plenty of resources to have a look from there, from the power and magic of Google. However, collecting like terms, otherwise known as simplifying expressions. This is where we're looking at the terms, getting them all together and basically tidying up our expression here. So one thing which is probably good to know here is the order in which I personally do it is we will go through terms of variables in alphabetical order. So we'll start with X, for example. We'll see if we've got any Y's after that, any Z's, so on and so forth. What you usually find is these usually have like X, Y, and Z in them, or A, B, and C, or L, M, and N. So usually it's a nice alphabetical order. Just be very careful about that. However, it does keep you on the straight and narrow. Then after that, we will deal with the normal numbers. These are like +3, -7, -24, or whatever. These are the ones where we just treat them like normal numbers. They do not have a variable stuck on the end, so there's no X, no Y. We just treat them like normal numbers. One very big thing to keep in mind here is mind your symbols. Symbols are very important here. It is, do not assume that everything is positive. Do not assume that every single term that you will see is positive. Keep a close eye for this. That will be the difference between getting a 6x or a 2x. So be very careful about that. If there's one part which you've got to be careful about, that's it. So what we're going to do here is we've got 3 different examples which we're going to go through. And first one we're going to do here is 9x plus 5 plus 3x plus 7. So what we're going to do is we're going to follow a process here. And I'm going to use a blue flavoured pen. So this one here, first of all, alphabetical order. So these are terms where we have variables in them. So in this case, we've got 9x and we've also got 3x. Now, that 9x, that is positive. If it doesn't have a symbol in front, we assume it's positive. Think of it like this. 3 plus 5. We know that 3 plus 5 is 8. However, you never see it like this. So we just assume that that 3 is positive. Same applies for algebra. We've just got a few letters in there. So, first one here, what we're going to do is we're going to have a plus 9x. We're going to have plus 3x as well. So a little bit of upstanding here. Plus 9x plus 3x, that will give us 12x. Again, we're not going to put a plus symbol on the front. Doesn't mean anything. Now, have we got any more letters we need to deal with? Have we got any y's or z's? We don't. So now we're going to move on to our second step, which is dealing with the normal numbers. So we've got a plus 5 and a plus 7. Plus 5, plus 7. Plus 5 and plus 7, well, 7 plus 5, that's 12, and it's positive 12. Remember, we need to know what symbol goes in front. That is your final answer. We've highlighted every term, we've dealt with every term, we've tidied it up. Now we can write all that as 12x plus 12. Next one after this is 3x plus 4 minus 5x minus 4. Interesting. So this one here, what we're going to do is once again go through alphabetical order. So we're going to have positive 3x to start with. And then this is where it starts to get a bit spicy. Remember, mind your symbols. This is minus 5x. We need to take care of that symbol. We need to respect it, otherwise it will bite and attack with 2 C's. So, minus 5x. So we now need to do 3 minus 5. So we're starting at 3 on our thermometer or number line. We're going down 5. We will get to negative 2. It's important that we put a negative 2 there. So in this case, we're going to have a negative at the front. And don't forget, the x stays there, unless we get to 0, where it just goes boom. It's nothing. Disappears. So next part after that is our numbers. We've got a plus 4 and we've got a minus 4. Plus 4 and minus 4. Well, if you start at 4 and you go down 4, you end up at 0. So it's nothing. There's nothing there. So there's no need to write anything here. We're done. We can write all of that just as minus 2x. Job done. So anything which you have which is 0, like 0x or 0z or 0y, just get rid of it. Doesn't need to be there. It cancels out entirely. It has no purpose. It just disappears. So, next one after this is example 3. Now, we're going to need to go in alphabetical order. So let's look at all of our terms here. We've got y. So we're going to deal with the y's first. 12y. So we'll put plus 12y. And then we've got minus 8y. And that's all of our y terms gathered up. Now we need to tidy them up. So, starting at 12, going down 8, we get to positive 4. Plus 4y, we'll just write it as 4y. There we are. And now we need to deal with the z's. So, the z's. Which terms have got z's in it? Well, we've got a plus 4z. And we've got a minus 3z. So, starting at 4, subtracting 3, we get to 1. Positive 1. Positive 1z. Now, don't forget, the whole purpose of algebra is to write things as short as possible. That 1 doesn't really serve a purpose. If you multiply like 1, if you do 1 times 7, it's 7. If you do 1 times 9, it's 9. If you do 1 times 99, it's 99. That multiplying by 1, it's as much use as a Magikarp using Splash. So, we just get rid of it. We just get rid of it. So all we're going to do, we're just going to write that as plus z. Next thing after that is, have we got any more terms which contain variables in them? We don't. So now we're going to move on to if we have any numbers. And we do. We have a minus 6. all by itself. Sad, bit of a Billy no mates. However, what we do is we still need to respect the fact it exists. So we need to write it down. And it's just a case of -6. Obviously, if you had stuff over here, you would need to deal with it, gather it up, do the calculation and write it down. Unless if it's 0, well, just go poof, like that. Next up, after this, is equations. We're going to be solving them. So, in other words, we get some variables and stuff like that. We get an extra little bit of information, and then we're going to find out what that mystery value is from the information. Ooh. I've turned the lights on now because it's getting a little dark. But solving equations is what we're going to do now. This is basically finding out the value of our unknown, or finding out the value of our unknown, so the letter involved. Now it's important that we get this in the form of an equation. You'll notice that we've now got equations because we've got an equal sign, we've got information on both sides of it as well. So we've got a lot more to deal with here. However, there's a lovely process which you can use to find this out. Now, there's two different little things to be aware of here when you're dealing with solving equations to find that mystery value. You might be able to work it off the top of your head. However, we want to see your working out. We don't want to just see an answer. We want to see that working out. So, first thing to be aware of here is when you're dealing with it, we're effectively doing BIDMAS or PEMDAS backwards. So you're going to undo all the addition and subtraction first. Then you're going to undo all the division and multiplication. Then undo any indices or exponents you've got. You'll probably not get that. And then after that, anything which is in brackets or parentheses, stuff like that. So, first thing we need to do is addition. Addition and subtraction, then division and multiplication, then indices, exponents, then brackets and parentheses. Now, another thing to also be aware of is the inverse functions. What undoes it? What undoes that thing which is going on in the calculation? So this is basically the mathematical version of clicking the undo button in Google Docs. If we have addition, our way of undoing addition is by subtraction. And likewise, if we have subtraction, the way of cancelling that out is doing addition. Multiplication and division, they're closely related as well. One of them cancels out the other as well. So if we've got division, we can get rid of that by doing a bit of multiplication. And then there's also this other one as well, squared. So if we have like x squared equals 36, we have to use a thing called the square root. It's that symbol there. Looks kind of like the Vans logo without the ands bit in it. Basically, what a square root is what number do I multiply by itself to get that number? So if x squared equals 36, what number do I multiply by itself to get to 36? Answer would be 6. It's a square number. We'll be doing a lot more of those in year 7, 8 and 9. So let's get cracking with these kinds of questions here. So first one we've got here is m divided by 4 equals 5. Now what we've got here is we have division. So let's look at our table and find out, oh, we've got division. We cancel that out with a bit of multiplication. We divided by 4, we click undo by multiplying by 4. So we're going to multiply 4 to both sides. Remember, it is important that whatever we do to one side of the equation, we do to the other, because that's an equal sign. That is an equal sign. Whatever's on the left has got to be the same as what is on the right. So multiply by 4 both sides. Divide by 4, multiply 4, cancelled out, so you just get m. And then we do 5 multiplied by 4, gives us 20. So, ta-da, m equals 20. You can replace that m, yeet that m out the window, replace with the number 20, and prove it by going 20 divided by 4 equals 5. Sounds right to me. Next one after this is x plus 22 equals 30. So we've got a bit of addition going on here. We've got to get rid of it. And how we're going to get rid of that is using addition's Thea sibling known as subtraction. So we're going to subtract 22 from both sides here. Now, x plus 22 minus 22, they get cancelled out. They just disappear. So we're left with just x. And then 30 minus 22, that gives us just 8. So x equals 8. Next up on the menu, 12p equals 96. Now, remember, as I said before earlier in this video, what is sticking that 12, our coefficient, and our variable p together? What is the glue which keeps them together? Remember, it's multiplication. We just don't like saying multiplication symbols when dealing with algebra. We want to write stuff as short as possible, as short and sweet as possible. So, multiplication we've got going on here, and how we'll do that is we do a bit of division. In this case, we're going to divide by 12. So p will be 8. There we go. There's one times table fact which you should be aware of as well. So knowing your times tables helps even in these cases. Next up, z minus 15 equals 85. Subtraction. How do we cancel it out? We do addition. So we're going to do adding 15. Z equals 85 plus 15, which will give us 100. Like that. So far what we have done is we have done one-step solving equations. It's only taken us one step to get from question to answer. Well, or from equation to solution. Now we're going to be dealing with two-step equations, and this is where our BIDMAS-PEMDAS rule comes in. We've got to do it backwards. Remember, what we're doing here, x divided by 7 minus 2 equals 9, is basically, I'm starting with a mystery number. I do not know what that number is. I've divided by 7, I have then subtracted by 2, my answer is 9. And then we need to think about what's going on backwards. Well, we subtracted by 2, so let's add 2. And then after that, we've got that divided by 7 here. So what do we do when we do that? We have to multiply by 7 to that answer we got before. It is BIDMAS backwards. So, first of all, there's that subtraction we need to get rid of. So, we're going to add 2. Now, don't forget, x divided by 7 is still a problem, but we're going to deal with it. So at this point, you should have x divided by 7 equals 11. And then we've got that pesky division we need to get rid of. So we're going to multiply by 7. That leaves us with x equals 77. Next up, 14p minus 70 equals 0. So I've got a mystery number. I've multiplied it by 14. I've subtracted it by 70. I'm at 0. And then I've got to go back on myself. Add 70. Divide by 14. You'll get back to where that mystery number is. So let's start off with the addition and subtraction. We're going to add 70 to both sides. That'll leave us with just 14p on the left. 0 plus 70, well, that gets us up to 70. And then from there, we've got to divide by 14. That will leave us with p equals 5. Now in both of these cases, what you can do is you can happily, with your answer here, so in this case, p equals 5, you can put it in there. 14 multiplied by 5, that is 70. Take away 70, and you get to 0. So that's what you need to know of. Remember, BIDMAS backwards, and also just know your inverses as well. Showing each and every step of your calculation, and showing a little bit of proof for your answer as well, goes a long way. Next up after this, we're going to do one problem on forming an equation, and then we're going to try and solve it. Ooh, multiple things all at once. How fancy. Okay, so now we're on to the real nitty-gritty of algebra, and this is problem solving. Now, problem solving, it can be very vast. It's a very vast part of problem solving with algebra. However, one top tip, a lot of the questions which we use for problem solving with algebra, they are usually a mishmash of algebra, of course, and geometry. You put them together, kind of like Marcus and Martinus. You never see them separate. They're usually together. Having Marcus on stage, you need to have Marcus and Martinus. So, here's an example question of what you're likely to see. So what it is a square has a perimeter, or umkrets, of 56 centimetres. Find the length of one side. Now, before we start this question, we need to think about what shape are we dealing with, because there's different properties we need to think about with different shapes. In this case, we've got a square. So the first thing you should be asking yourself is, what makes a square a square? Well, it's got 4 sides, but the thing which really separates it from all the other shapes is all those sides are of the same length, and we've got 4 of them. So we've got a 2x already, but we're going to also put some other 2x on. One top tip, label every side. Even if it's not on there, I would say label each and every side, just so then you know exactly what you're dealing with and all the information. We don't like blank sides. We don't like blank sides. Draw all over your work, put as much information on as possible. Now, we've got a 2x already. Now I've got another one, another one, and another one. And we're finding perimeter. Don't forget, perimeter is around the shape. It's not what's inside. That's called area. But perimeter, or encrats, is around the shape. So we have 2x, another 2x, another 2x, another 2x. In total, we have 8x. So we've got 8x. Now, that is equal to the information we get given in here. We are told that the perimeter is 56 centimetres. So we'll separate this to 56. Now what we need to do is we need to solve this just for 1x. So we're going to divide by 8 on both sides. You can also use peg finger method then, cover it up, cover the x up. 8 times equals 56, and that is 7. So x equals 7. Now, at this point, you may think, are we done? However, if x was 7, if it was 7, 7, 7, 7, that would be 28 centimetres. However, no, we need to do a little bit of substitution. So what we should do is we're going to put these two together. 2x, 2, and then 7. That gives you 14. So each side is 14 centimetres. Conclude with a little sentence or a statement like that. And the job is what we call a good one. So that's what one of the example questions you may get. We'll do another one in just a moment, right now, after this commercial break, which won't even exist. Okay, we're now on to question 2 here. This time we're dealing with a rectangle, and we've spiced it up a little bit. You'll see the area makes an appearance right now. So what we're told is the perimeter of this rectangle is 48 centimetres. We need to find the area of the rectangle. Now the first thing we get told here is, well, it's a rectangle, and we've got to think about, well, what makes a rectangle a rectangle? Well, it has 4 sides, and we've got 2 pairs of sides the same length, unlike a square where all of them are the same length. So what we need to think about is perimeter. So we're adding the lengths along here. Now we've got 2 blank sides. We don't like blank sides when we're dealing with perimeter. Every single side must be labelled. So what I would do first of all, draw all over your work. That 9 there must mean we've got a 9 here, and we've got a 3x over here. And now we need to deal with the perimeter. So we're going to add up all the sides. So we'll have 9, we'll go in a clockwise direction. 9 plus 3x plus 9 plus 3x. And that's going to equal that little bit of information there, little gem, 48. Now, that will obviously be sent because we'll deal with units later on our final answer. At the minute, this is a little bit messy. So cast your mind back to when we did simplifying of expressions. Let's tidy it up a little bit. So alphabetically, we've got a 3x and a 3x, so that'll give us 6x. Positive 9 and positive 9 give us positive 18 equals 48. So this is our little perimeter equation we've made. We've made a cheeky little perimeter equation. And now what we need to do is we need to, well, basically find out what the value of x is, so then we can get that 3x side length there. So first of all, it's going to be something plus 18 equals 48. Take away 18 from both sides, 6x equals 30. That should be your first step, no matter what method you're using. Then you should be dividing by 6 on both sides. You'll find that x is 5. So if x is 5, don't forget this 3x there. We can't exactly put x into a calculator, but we can put 3 times 5 into a calculator. We're substituting this 5 in the place of the x, given the information we've got here. So that 13 we can actually write as 15. 3 times 5. So we've got 15 and we've now got 9. Using that information, we can now work out area Don't forget classic length times width. Now, we've got our length and we've got our width, so it's just going to be a case of 15 multiplied by 9. You do have written methods to use at your disposal. Please use them. Now, 15 multiplied by 9, it'll be 10 times 9 plus 5 times 9, so that's 90 plus 45, gives you 135. Now, don't forget here, this is one very important part, which I see a lot of people miss out. We do get given units here. These are all in centimetres. So our answer is going to be centimetres, but don't forget its area. So it's going to be centimetres squared with a little 2 in the corner. 135 centimetres squared. Boomity, boomity, boom. So that is question 2 all done. Question 3, going to do a little bit more on shapes, and then we'll deal with the question all in relation to sporks. Okay, so now we're dealing with compound shapes. These are basically two shapes stuck together. As you can see here, it's basically a rectangle superglued onto the side of a rectangle. It's called a compound shape because it's a compound of two shapes. Cool. Now, what we're first being asked here is calculate the perimeter of the shape as a fully simplified expression. Now, we should all be aware at this point, especially from questions 1 and 2, that perimeter is counting up the length of all the sides, the sum of all the side lengths. Now, the first thing we need to think about is every single side length here labelled? Now, we've got those ones, happy days, happy days, happy days, but oh dear and oh dear. We've got 2 which are missing. So before we need to crack with this one, we can't exactly ignore these sides because, well, we're not working out a perimeter, we're working out something weird. So what we need to do is we need to use the information which is given to us. So the first one here is, what I would say is scan up like this and then scan left to right as well, because that's where you're going to find the kind of information to crack those missing side lengths. So we're going to scan upwards here. Now the side lengths we've got here are 4x, which is a horizontal. We've got this mystery horizontal side length, and we've got this horizontal side length, which is 11x. Now 11x, imagine these are like pieces of string. You've got 11x all the way here. Then you've got 2 other pieces of string. But if you add these 2 together, you will get these 2. And we know that this one's 4x, because that's given to us here. So 4x plus something gives us 11x. In this case, it's going to be 7x, because 4x plus 7x will give us 11x. So that's that side length all sorted. Now we've got just this other one to deal with. Now, we've got 3x plus 2 there, one vertical length. We've got another vertical length here, which we don't yet know about, but we do know this big boy right here, and that's 7x plus 2. So what we need to do is we need to think about, well, that's the longer side. So this one, add this one, will give us this one. So 3x plus 2 plus gives us 7x plus 2, and that is 4x. So 4x is going to go right there. Right, now we're at the stage where we can we can get everything all together and write it as a very big expression. So let's go round from the top. We've got 4x. I'll mark them off as I go, so I don't miss anything out or double count anything. 3x plus 2 plus 7x plus 4x plus 11x plus 7x plus 2. Now, my word, we've nearly run out of space here. Hello, I'm nearly falling off the screen. This is quite long. This is quite long. It's a little bit cluttered. So what we need to do is we need to simplify it. In other words, let's tidy this up. Let's make it nice and sweet. Also, it does say in the question, fully simplified expression. So far, we've only got a half-baked answer. We need to make sure that we're answering the question fully. So let's start off with the x's. So 4, positive 7, positive 14, positive 18, positive 29, positive 36. So that's going to be 36x. Don't forget the x stays. Now let's deal with the normal numbers. Plus 2 plus 4. So you've got 36x plus 4. Done. So now we've got a perimeter expression. We're now being told that given that x equals 5 centimetres, let's try and work out the actual perimeter of the shape. So what we're going to do is we're going to use our 36x plus 4. And we're going to do a little thing known in the trade as substitution, otherwise known as ersättning, procentscal. So this one here, basically, we're going to get that x, we're going to yeet it out the window, and we're going to replace it with a number 5 here. Now, it does say centimetres, so state your units at the end of your answer. Don't forget the glue as well, sticking your number and your letter together, is multiplication. So we're doing multiplication here. 36 times by 5 plus 4. 36 times by 5, that's a big boy calculation. Usually anything above 12 times 12 requires abstaining. If you happen to do it yourself, you should get to 180 for this. 36 times 5 is 180. You've got plus 4. That will give you 184 centimetres. Don't forget your centimetres. It does say so here. If it says in a question, get it in your answer as well. That means you cannot argue, it means it's indefensible about your communication marks. So that's how we do compound shapes. This one here, that one, all good. Let's have a go now at a question where we're going to make our own equation up. It's kind of a create your own question, kind of like when you make your own pizza. That's cool. Okay, so question number 4 here. So many words, we've got to get it all into algebra. Oof. So let's go through the question first of all. Yoshi has some sporks. Cool. Alma has 4 less sporks than Yoshi. Bella has 3 times as many as Yoshi and an extra 2. In total, they have 166 sporks. That's a lot of sporks. So what we want to find out is how many sporks does each person have? Now, with this kind of question, this one, we need to kind of get all of these sentences into really simplified algebra. So what we're going to do is first of all think about what's our starting point? Who is our starting point? Who's our point of comparison for every single person involved? And in this case, it's Yoshi. So Yoshi's going to be our starting point. Yoshi's number of sporks, do we know how many sporks Yoshi has? Unfortunately, we don't. It is a mystery number, and don't forget, a mystery number can just be simply shown as a variable in algebra. So we'll go for the classic one, we'll go for x. Actually, you know what? It's Yoshi. Why? Why not? Pardon the pun. Right, Alma has 4 less sporks than Yoshi. So in this case, we've got Yoshi's number, but we've got 4, we've taken 4 away. So in that case, it's y minus 4. Be very careful with the vocabulary here. Y minus, oh goodness, that's a plus. Oh, we don't want that there. Y minus 4. And now we're told that Bella has 3 times as many as Yoshi and an extra 2. So let's first of all deal with the 3 times part. 3 lots of Yoshi sporks, well that would be 3y. And an extra 2, so 3 times as many, and we've given Bella an extra 2, so 3y plus 2. So we've now got expressions for each and every person. This is Yoshi's expression, this is Alma's expression, and this is Bella's expression. We're told in total they have 166 sporks. Important word here, total. And it's involving every single person. So we need to make sure every single character is accounted for here. We don't want to see Yoshi getting purged, we don't want to see Alma or Bella getting purged any part along this question. So what we're going to do first of all is we're going to write these out. So let's first of all account for Yoshi, which was shown as a y, and don't forget, total. Then we're going to deal with Alma. Alma's our other character in here, so y minus 2. And then we've got Bella as well. So that's plus because total again, 3y minus 2. So we've got Yoshi's number of sporks, Alma's number of sporks, and Bella's number of sporks. And we're told that in total they equal 166. So what we need to do is let's try and simplify this up, because at the minute it's a little bit messy and a little bit tough to work with. So we've got 1y here, that's a second, that's a fifth, positive 5y. Mind your symbols, especially for the next bit. 5y. And then we're going at -2. Good grief, have I wrote that wrong? Yes, I have. Please, my apologies here. Yeah, there's a -4 there and a +2 there. My apologies for that. Even the best of us make mistakes. And the y's are fine, the y's are intact. So -4 plus 2, think like a thermometer or a number line. It is -4 degrees outside. It is getting 2 degrees warmer. Therefore, what temperature is it now? It's -2. Mind your symbols. -2 equals 166. Okay, so what we need to do is we need to find out what these are right here. So we're going to use Pekfingermetoden again. So something -2 equals 166. That something would be, in this case, 5x, and it will be equal to 168. And then we'll need to divide by 5 on both of these sides. This is quite nasty. This is quite nasty, and I apologise for this. You will not get a question involving a decimal. This one does give you a decimal, and well, you can't get a fraction of a spork. So yeah, when you're doing these kinds of questions, it will not be like this. If you're expecting, like, if it's involving Billy's Pizzas, you'll not get 2.5 Billy's Pizzas, probably. You probably won't get that. You'll get a whole number, or an integer if you want to be nerdy with all the math stuff. But in this case, 168 divided by 5 is actually 33.6. So each person gets the absolutely ridiculous number of 33.6 sporks. How you get 0.6 of a spork, I do not know. So what we now need to do is we need to use this information to work out how many sporks each person actually does have. So in this case, Yoshi, it's just a case of, well, copying it down. Also, why have I gone from y to x? These should be y's. This question's not going very well. It's going down kind of like a lead balloon. So 5y and y there. So that'll be 33.6. And then in this case, it's going to be that, take away 4. You get 29.6. And then, oh goodness, that's spicy. Well, 33.6 times by 3. And that's going to be 99, 1.8 onto there, 100.8. And then we've also got some, I believe, irritating year 5s at the door. Apologies for the interruption. And then we'll add an extra 2 to that. So that should be 100.8. Yeah, I think, so let's see. 33.6, take away 4. Yep, that gives us that. And 33.6 multiplied by 3, 99, add another 1.8 onto that. Excellent. No, because I need to still add the extra 2, don't I? Silly me. Right, let's just add these up. 12, 20. So let's have a 2 as a minna. 3, 12, 14, 16. 6 there, minna there. 3, 2, 1. Boom, that's a 6. And 1. 166 sporks exactly. So some people got like 0.6 of a spork, some people got 0.8 of a spork. Questions like this, you're unlikely to get decimals. It will probably be whole numbers. On to the next part, sequences, which is, thankfully, the last thing you need to know for all of this algebra section. Ooh. Right, we're now moving on to sequences. This is fairly short and sweet, so rather pleasant, which is very, very good. So what we're doing is we are going to have, I've got some year 6s at the door again, oh dear. Figure 1 here, we're going to be talking about Billy's Pizzas, because why not? We've talked about sporks, we need to do Billy's Pizzas as well to do the whole thing justice. So first of all, figure 1 here has 3 Billy's Pizzas. We've got 1, 2, 3 Billy's Pizzas. Now the next figure in our sequence, this is basically like each part in our sequence here. So the second one will be figure 2. The 50th would be figure 50, which involve a lot of writing there. However, figure 2 has 5 Billy's Pizzas. And then figure 3 has 7 Billy's Pizzas. So what I've got here is a lovely table. We've got a very nice table here for the number of Billy's Pizzas we've got in each figure. Now we're going to, what we like to call in maths, tabulate the data, which means just stick it into a table. So figure 1 we had 3. So let's bop a 3 there. And then figure 2 we had 5. And then figure 3 we had 7. Now, figure 4, we might be spotting a pattern here. One thing to spot in these patterns is there a common difference? Is there something you are doing each and every step to get from one figure to the next? In this case, we're adding 2. So we've gone from 3, add 2 to get to 5, add 2 to that to get to 7. Add 2 to that, you'll get to 9. Boom. There we go. Some questions may ask you to draw them. So in this case, we need to draw 9 Billy's Pizzas, which I'm just going to indicate by drawing rectangles with a line in them because I can't be bothered to write Billy's 9 times over. But the drawings you usually get are fairly basic, so that's rather pleasant. There we go, so we got 9. Now, what we need to do is we have enough information here to find out our nth term rule. Now, our nth term rule is basically a one-size-fits-all rule for every single value we're going to face in our Billy's Pizza sequence. So what we need to do is we need to think about how do we get that? How do we find our nth term rule with this information? Because we need to make sure it works every single time. So what we're going to do is we're going to write out 3, 5, 7, and 9. And we've got to think about what are we doing to get from each and every step. Well, each and every time we're adding 2, aren't we? This is basically what we're doing is it's just a pretty weird 2 times table. So we're going to write whatever we get here, that's going to be our n coefficients. So in this case, first part of our nth term rule is going to be 2n. Now 2n's a 2 times table, so up above this we're just going to write 2 times table. So the first number in your 2 times table is 2, then 4, then 6, and then 8. Now we need to think about what are we doing each and every step here. Well, 2 to 3, 4 to 5, 6 to 7, 8 to 9, we are adding 1 each and every time. So it's basically the little thing we do with our 2 times table to correct it so that we get these values here. So we get 2n plus 1. That is our nth term rule. So we're going to bop that in our table. We can do a little check through with this. Let's do figure 2, because in that case n would have a value of 2. Double it, you get to 4. Add 1, ooh, you get to 5. If you get 4, double 4, you get to 8. Add 1 to that, you get to 9. So it's excellent. So it works. It works for early numbers because don't forget nth term rule has to work for every single value in our sequence. Now, some people might be thinking, why on earth do we need to do the nth term rule? Well, imagine the nth term rule. Think of it like a teleportation device. You can use it to teleport from like the 5th term in your sequence, which you can maybe write out or just work out in your head, to one which is 70, the 70th number of, like, the 70th figure in our sequence. Because if we're doing this, we'd probably run out of space in the board. My pen would run out of ink. So what we can do is we can use this to teleport to what the 70th term in our sequence is and how many Billy's Pizzas are waiting there for us to eat. So 2n plus 1, we are going to substitute, or in other words, yeet out the n and replace it with the number 70. So here's a little bit of working. Oops, there's a bracket. 2 times 70 plus 1. Well, it's 2 times 7 with a 0 on the end, so that's 140. Plus 1. Put an equals there just to indicate what it is. 141. There we go. So 141 Billy's Pizzas are waiting there for you to feast on or whatever. So that's how this works. Just be very wary with this. You may be asked, draw the next thing in the sequence. You might be asked, what do I do to get from one figure to the next? Or you might even be asked, what is the nth term rule, which you can find out here. That's all the content. Time for a little quick recap of everything that we've covered. So finally, just to sum everything up, here's a little conclusion and overview of everything that we've covered in this video, just as a little bit of a checklist to make sure that you've got everything and that you feel confident in algebra. First thing that we covered was some key words. These were like coefficient, variable, term, operation, and numeric. Sorry, I messed up there. A numeric expression and an algebraic expression as well. Make sure you know those words. They will be golden for your reasoning. So make sure you're using those words rather than letters. Use variables rather than like sum or something like that. Use calculation if it's just a generic thing, or expression when it's an exact expression. Then we moved on to writing expressions. Basically, these are all the rules we have with algebra. Make sure that we're using the proper notation for everything. Make sure it's not like 7 times x. It should just be 7x, as short and sweet as possible. And also all the keywords and synonyms we have for maths as well. So product means multiplication. Quotient means division. Make sure you're aware of those. There will be a little bit of a link in the description to help you go over those if you need a little help with that. And then after that, we also did some simplifying expressions, otherwise known as collecting like terms. This is when you got a lot of clutter in your expression, and we tidy it up to make it look like something very short and sweet, which is lovely. 3 words though, mind your symbols. Remember, a negative can cause a lot of bother. Not everything in maths is positive. It's not all sunshine and rainbows, unfortunately. Sometimes some expressions and equations do feel a little bit negative, and we need to look after them, just like any other number. So, after that, we also did solving equations. The 2 methods for that, you've got pekfingermetoden, so it's basically what plus this equals 7, and what plus 4 equals 9 or whatever, doing that. Or you can use your BIDMAS backwards rule in conjunction with the undo functions. Remember, addition and subtraction, multiplication and division. Also, sometimes square and square root as well. So just be aware of those. Then after that, we did a little bit of problem solving. This is where geometry comes into the picture, or comes into the equation, pardon the pun. So remember, what makes a square? What makes a rectangle a rectangle? Compound shapes, know how to deal with those. Usually look like L shapes, really. Just be very careful. Make sure you know your perimeter from your area as well for those kinds of questions. And then finally, to finish up, we did a little bit on sequences. Basically, here's a little sequence. What would the next pattern look like? You might ask me, like, draw what the next pattern will be like. You might be asked, like, how many matchsticks will be in, like, the 7th pattern. Or you might be able to be asked, what's the nth term rule? So basically getting all the information you've got, putting it into some algebra, and then from there you'll be able to work out like what's the 45th one in the sequence without writing out the previous 44 terms in your sequence. So there's some good top tips. There'll be further links in the description as to where you can find extra information, also some study tips as well. Getting this stuff into a big mind map on a piece of A3 paper. Coloured pens, opportunity galore here, so get creative with this kind of thing. Algebra is very good fun, and actually you can use coloured pens in it quite a lot. So that's all of this for algebra. Little recap there. Thank you very much for watching. Don't forget to like and subscribe for more maths content with me, Nick Longridge. See you around. Ta-ra.